let us solve one problem on entry deterrence, or you can take this as an example. Now, suppose there are two firms, firm 1 and firm 2, market demand function is this, and Q1 and Q2 are the outputs of firm 1 and firm 2. P is the market price here. In stage 1, firm decides the amount of capacity, that is K1. The production function is such that to produce 1 unit of output, each firm requires 1 unit of labor and 1 unit of capital. This is exactly same as the Dixit model. The cost of labor is W per unit of labor and the cost of capital is R per unit of capital. Amount of capacity is same as the amount of capital. Okay? And in stage 2, firm 2 observes the capacity of firm 1 and decides whether to enter the market or not to enter. If firm 2 decides to enter the market in stage 2, there is Cournot competition between firm 1 and firm 2 in stage 2. So, in stage 2 there are two things that is being decided. So, first firm 2 decides whether to enter or not, and once it enters, then there is Cournot competition between firm 1 and firm 2. And firm 2 decides the amount of capacity in stage 2 only. So, only firm 2 has to incur a fixed cost of amount F, which is the entry cost. Firm 1 has no entry cost because it is an incumbent firm, and firm 2 has an entry cost because it is an entrant firm. And now, we will show all the possible outcomes in the Dixit model based on providing conditions on AW, because these are the parameters in this model. So, we will find them. So, first suppose K1 is the capacity of firm 1 in stage 1. So, this is K1. Okay. Now, let us move, and suppose firm 2 enters. Okay. Then profit of firm 1 is A minus Q1 Q2 this if Q1 is less than equal to K1, and otherwise it is this, if because the expenditure on the capacity is already borne in the stage 1. Okay. So, we get this, and profit of firm 2 is, and this is the total revenue. Yes. Now, from here we can derive the reaction function of firm 1 and firm 2. So, so we get and this gives me this is the first order condition implying and So, these are the reaction functions, and if we plot them, we will get something like this. Yes, this is the reaction function of form 2. This is point T, this is the point V that we have used, and suppose this, if this is the capacity, then the reaction function of form 1 is this thick line. If this is the capacity. If this is K is the capacity, then the reaction function of form 1 is this green line, this. So, we get the reaction function of this nature based on the exact value of capacity. Okay. Now, we will find out the output in this point T and V, because our analysis is dependent on these two outputs. So, this is when this reaction function intersects with this reaction function. So, T point at T these two intersects. So, from this we get that Q1 is we get this. So, this is the point at T. Okay. At phi, we get the reaction function of form 1 is this, and reaction function of form 2 is this. So, solving these two, we get so this is at the point V. Okay. So, we get that this is less than this and this is greater than this. So, this point we have one. Now, we will find the limit output of form 1. Form 1. Limit output of form 1 is such that it is Q1L suppose. So, at Q1L, okay, I have made a mistake here. So, while specifying the profit function of form 2 here, I have to specify the entry cost F also. Okay. But this is a fixed cost, so it is not going to appear in the reaction function of form 2. Okay. Now, into this, and we know from the reaction function Q2 is it is this. So, it is this. This is the reaction function of form 2, and we have got this. So, plug in the reaction function here. We get this, and if we solve this, we get this. Now, we have to find out Q1 such that this is equal to 0. So, we get equating this equal to 0, we get so this is the limit output. Okay. Now, let us again draw the reaction curves. So, this is the point T, this is the point V, and we know this is the monopoly outcome of form. So, this is it is in this reaction function of form. So, Q1 is it is this here. Now, Q2 is equal to 0. So, Q1m is it is this. So, this is the monopoly output. This is the limit output. Now, we have to find out the Stackelberg thing here. So, Stackelberg thing, it is something like this. Okay. It is something like this. So, this point. So, how do we find the Stackelberg thing? So, this is the profit function of form 1. You can write it in this form. If we take this reaction function, because this reaction function means that its capacity is less than what is the amount of output it is producing, right. So, now here we know the reaction function of form 2. It is this. Plug in this here, we will get Now, optimize this. This is done in the Stackelberg. We get equal to 0. So, from this we get so in this example we get that Q1M is equal to Q1S. Okay. And we have got this. Now, we have to find out this. So, this Stackelberg we have got this to be same. We have to find out this point. This is S naught Q1 S naught. So, how do we find Q1 S naught? So, Stackelberg profit, if you substitute that here, Stackelberg profit is, so K here, if you look at this here, K will not be more than, should not have excess capacity because it is going to, and should. So, profit of firm 1, in this case you can output is this. So, this Stackelberg profit, you can write this A plus A minus, because if you take this common, you get this minus A minus, this plus. So, you will get this only, because actually if you look at this term, what you will get that this K1 is actually equal to this Stackelberg output, and so that cost is borne in stage 1. You will not get any additional cost here in terms of the A, but if you remove it and add it together, you will get the profit in this term only. So, that in this term only, because what you can do is you can write it in this term. If you simply take this position or simply set this, okay, Stackelberg thing, which we have got from this here, this point. Now, how to find out this thing? This we can find out, because here I have, when I have got this Stackelberg, I have simply taken the Stackelberg profit when we are not taking this capacity thing anymore consideration. Okay. Actually, the capacity will be same as the output, and so we will get the same thing if we combine the cost of the stage 1 and the profit in stage 2 together. Okay. So, this is going to be the total profit when we have the outcome as the Stackelberg thing. Okay. Or you can simply take this and then go ahead. And this A is this is the, now when Q2 is 0, Q2 is 0 and fix this profit at the Stackelberg thing. Okay, so here I can write this in terms of this also, if we strictly follow this here, then we will get this. we will have this is equal to 0. So, we will have this term is cancels out. We get this. So, from this we get this divided by this. So, which is this. If we this is what this is the this q1 not as dot this output is this. This. Now, this the minus CA will be, if we take the, it will be this one. So, we do not bother, we require this. Okay. Now, we have derived all the outputs. So, what outputs we have? We have Q1T, we have Q1V, we have Q1M, we have Q1S, we have Q1S naught, we have Q1L. Now, let us do the case 1. If Q1S is less than Q1T. So, this implies A minus mu, this is less than this. So, this means this is the case. In this situation, there is, if this is the case, then what we have got? We have got that Q1 this Q1 is this. So, firm 1 will. So, this is the case of blockaded monopoly. Next, case 2. So, in this case, what we had? Profit of firm 2 at T is. Next, case 2, profit of firm 2 is positive, this is also positive. So, this implies Q1L is greater than Q1V. So, this implies it is this. So, if this is the case, then what do we see? Here QL is somewhere here. It is this. If this is the case, and we know Stackelberg output is this. So, here in this case Q1 is going to be Q1S and it is going to be, and here Q1 is going to be the Stackelberg outcome, this, and Q2 is going to be this, because here it is like this. So, if it tries to, it will not be able to deter, farm 1 will not be able to deter the entry of farm 2, because if it has this much amount of capacity, then output is going to be this. Now, if it produces capacity like Stackelberg, it is here, reaction function is this. So, it is reaction function of farm 2 is this is R2 and this is R1. So, he intersect at this is the outcome. So, it is the Stackelberg outcome, and farm 1 can ensure Stackelberg outcome by having the capacity as the Stackelberg outcome, capacity of the Stackelberg outcome. So, farm 1 will do that. It will accommodate the entry of farm 2 and it will have a capacity of the Stackelberg, and the outcome is going to be the Stackelberg. Now, here we had I had earlier while discussing this problem, not problem, in the main discussion we had taken two cases where this point is greater than this or this point is less than, but we will not require this because the Stackelberg thing is less than the Q this, because we have seen that here this is always less than this. Because of this we do not require any further here. We will only get one outcome in case 2. Now, move to case 3. In case 3, we have profit of farm 2 is positive at T and it is negative at this. So, in this case, the first case A what we have is so this is the, so from this we get this, and from this we know then it is this outcome, just opposite of that. It is this. So, f should lie in this range to get this. So, here again we have blockaded monopoly and K1 is equal to the monopoly output and this is equal to and Q2 is equal to 0. So, farm 1 deters the entry of farm 2. Okay. So, this is 1. Next, let us tree B. Here Q1L is greater than N. Okay. Now, this has we had taken one more case, it is like this, but we know in our case is equal to. So, we will have only this case. Because of this, we will not have this case, okay? Because in this example, we do not get anything like this, because this is equal to this. So, we get this. Now, here this implies that should be here. But we have one more condition, that is Q1L is less than Q1V. So, from here we get this is less than this, right. So, here we get this will give me this condition. This is the case. So, we get this. So, we just the sign is opposite. Okay, and you can see that this is less than this. Now, here what we are getting? We are getting this is the reaction function of farm 2 and this is point T, this is point V. This is Q1M is equal to Q1S. So, QL lie here. This is point is Q1V, this is this point. So, in this range Q1 L lie. Okay. Now, if it lie here, this is the Stackelberg thing, right. Now, if it produces the Stackelberg thing, then it is going to be like this, right, and it will accommodate the entry, right. Now, if it keeps the capacity as this, then it is going to deter. Now, the PA is whether it is going to ensure this or not, deter or it is going to accommodate, because if it keeps K1 capacity as the Stackelberg thing, then it is accommodate. So, that we can compare looking at this point. Now, here we can compare first this. Whether this output can be greater than the this output. Now, if we take this here, if we take this this and we get this thing, and at the same time we require Q1V to be greater than Q1L. So, we this we have got from this. So, you have to calculate that whether this is less than this, because f whether this is greater than this, because f has to be less than this amount and f has to be greater than this amount. Okay. So, this is, so you compare this now. If this is greater, suppose if this is true, then what it means? So, then this means that this point is T, this point is V, Q1, Q2, this is Qm, which is equal to Qs. So, this is Qs, this is Q1S naught. Suppose this point is Q1L and this point is Q1V. Now, if it accommodates, then what is going to happen? If it accommodates, it is going to get a profit of, it can do the Stackelberg and it is going to get this profit, right. Now, it will be at this here. Here we have this is less than, okay, I have made this mistake. So, this point is Q1L. Okay. Now, if so, this is the isoprofit curve of the farm 1 when it is acting, when it is getting the Stackelberg outcome, and if farm 2 produces 0, its profit is this point. But if it deters the entry by having capacity as this much, K1 equal to QL, then the reaction function of farm 1 is this, outcome is this. This is closer to this monopoly than this. So, here in this situation, when Q1L is less than Q1S naught, then Q1, then K1 is actually equal to QL, which is equal to this, and farm 1 deters the entry of farm 2. But in this situation, if we have this, Okay, we have this, okay, and we have this. This should be opposite side. Okay. It should be this, and so here this is not binding at least, and this is binding, whichever. You have to check that. If this is true, then it will choose this and it will deter the entry of this. But if the case is opposite, that is, if Q1 this is greater than Q1 S naught, that means you just change the sign of this, that is √2 minus 1 for √2, it should be this here. If this is the case, and it has to be okay. We get this. So, when both this condition is satisfied, then we get a situation something like this. This is T, this is V, Qm is equal to Q1 S to Q1, this is the, and so this point is Q1 S naught, and this is suppose Q1 L, this is Q1 V. So, here Q1 L is greater than Q1. Now, here Q1 L is greater than Q1 S naught. This. In this situation, which is suppose C, in this situation, what do we get? So, this gives us this condition, these two conditions, F should lie within this range, then this gives us what? So, it tells us that if firm 1 wants to deter, it will have to need to have this much capacity, then the outcome is this. So, it is further away from the monopoly, and this is the isoprofit curve of the Stackelberg, and this is the isoprofit curve effect. So, firm 1 here accommodates the entry of firm 2, and K1 is equal to K1S, and it is equal to A. This. Okay. So, when this is the A, final outcome, there is in the Cournot competition is going to be like this, and this is going to be the outcome, right? Going to be this and Q2. Okay. So, these are all the possible outcomes that we get in this example of entry deterrence. Here we do not get one possibility because we have this situation. Because of Q1S is equal to Q1M. So, in case 2 we are having only one case. So, we do not have many possibilities in case 2. Okay. So, thank you.